Hello, we are officially live. Right on schedule, right on time. I'm sure there's going to be quite a few continuing to join us here right at the start of the hour, but we're going to go ahead and get started. So thanks so much for joining us and welcome to today's Stanley Talks webinar, EV Safety Solutions, Thermal and Pressure Management in Battery Systems. My name is Brittany Glow. I'm the Marketing Manager for North America and Automotive here at Stanley Engineered Fastening and also your host for today. Before we get started, just a few housekeeping things to help you navigate the platform a little bit better over the course of this webinar. There's a widget called Ask a Question. Please use this widget to submit any questions you may have for the speakers to answer during the Q&A session later on. You'll also see two separate Book a Meeting widgets segmented by region. If at any point during the webinar you decide you'd like to meet with our team to discuss these topics a little bit further, you can schedule time directly through either of those widgets for North America and the rest of the world, respectively. The related content widget has downloadable resources that you can take with you from today's event, and the media player widget will display any videos played throughout today's webinar. So let's get started. We are very excited to have two of our engineering experts with us here today, Doctor of Engineering Matthias Wisling, our Vice President of Global Technology and Innovation in Fasteners, and Jarno van Gompo, Business Development Manager of Global E-Mobility, here to share their insights around the current state and challenges being faced with proper regulation of heat and pressure in EV battery systems. So over the next 30 minutes, we'll start with just a brief introduction of who we are. Then our featured speakers will discuss some of the major issues in today's battery technology, as well as some exciting innovations on the horizon to help us all solve this challenge together. So first off, who we are. For those of you who don't know us, we are Stanley Engineered Fastening. We are a part of the industrial division within Stanley Black & Decker. As part of this global organization, we have over 56,000 employees in 60 countries around the world, 21 of which being home to our dedicated production facilities, providing local expertise where you need it most. We hold over 13,000 registered and active global patents, and within the automotive division, 90% of all new automobiles and light trucks use our fasteners. So even if you don't know us, there's a good chance our products or systems are used in the vehicles that you already build or drive. Because that's what we do, and we've been doing it for the last century. Today, we're proud to deliver the world's #1 fastening systems, but even more proud of the passionate team of problem solvers that we put to work for you each and every day. And with the people, systems, and wide-ranging portfolio of brands and products, we've got everything you need in-house to be your go-to single-source supplier around the world. So now that we're all a little bit better acquainted, let's go ahead and jump into our first segment on thermal runaway. Over to you, Matthias.
Thank you, Whitney. Good morning, good afternoon, good evening, and hello to all of you. It is actually a big pleasure and also an honor for me to speak to you about thermal management today. There is so much exciting innovation ongoing in electrification. Next slide, please. So thermal management efforts for batteries varies depending on the applications and branches. It can be classified based on the charging rate and the lifetime of the battery. Consumer electronics usually require relatively less thermal management since charging rate as well as lifetime are in low or moderate area. On the other hand, thermal management for the application automotive is very sensitive and high safety measures are required. Fast charging, long lifetime, thermal propagation control becomes significantly important. Stanley Black & Decker are going to cover solutions for all these areas. Next slide, please. We all know that many fire accidents of electrical cars as well as gas cars were reported. The statistical reports of Auto Insurance EZ Company and Recall shows about 3.5% of all hybrid cars and 1.5% of gas cars got fire. So that means about 35,000 hybrid cars out of 1 million manufactured hybrid cars have gotten in fire. So the risk of fire is high. The recall action, as we know, for OEMs are very expensive. Therefore, some measures and solutions are absolutely required here. Next slide, please. Some regulations for electrical vehicles are already established in order to increase safety of passengers. A popular one is the 5-minute warning in China. We believe that such regulation will be given in Europe as well as North America soon. As it is shown in the right side picture, thermal runaway is a very fast process. It generates a lot of heat and increases temperature about 700 degrees Celsius in a very short time. Because of the fast heating process, it is a big challenge to meet this 5-minute regulation. The battery, as well as its components, must be safe with high temperature resistance. Thermal propagation to other cells must be prevented. And the damage and thermal runaway must be isolated and controlled in order to give 5 minutes safety time to passengers. Next slide, please. There are several reasons and failures which lead to starting a thermal runaway, such as overcharging in most cases, over temperature, or penetrating external objects inside cells, external or internal shortcuts, system failures, production failures, and also crash. The risk of thermal runaway is high. The thermal runaway process starts with exothermic reaction, generating an extremely amount of heat in a very short time. And a huge amount of heat cannot transfer out of the battery fastly enough, and therefore the cell gets enough energy for starting a fire. After that begins a domino effect, with penetrating enough heat to other cells for starting thermal runaway of the other cells. So we want to somehow control or to manage the temperatures in the battery, ideally at the cells. Next slide, please. So thermal management comes into play here. Next slide, please. So why thermal management is so important for batteries? There are 4 key aspects here. The first one is thermal management of cells and battery has a significant effect on increasing performance and lifetime. So we all know that the cell performance and lifetime of cells drop extremely with low or high temperature. You might have experienced that already with your cell phone. But it is not only lifetime and not only performance. Thermal management reduces the risk of thermal runaway and gives a better charging rate. Fast charging is only possible with a good thermal management of cells and other components. So next slide, please. So if you look in the automotive industry, there are 4 available approaches to help to control thermal runaway at the moment. The first one, using insulation material with very low thermal conductivity between the cells, such as safety separators. However, this cannot stop thermal runaway in all cases. The second approach here is using insulation material inside the pack. For example, foam material. This delays the thermal propagation, but it can also not completely stop it in all cases. And as you can imagine, this also increases the weight of the battery. The third approach here is using insulation between the pack and the vehicle. So with a high temperature resistant material. And the first approach is using isolation cells and pack. So using isolation, the cell and the pack with a strong housing out of steel or similar, for example. There's one thing important. All 4 options cannot completely stop thermal runaway, but they give more time to passengers to be safe. These methods only make the thermal propagation less fast. On the other hand, these methods have even a negative effect on thermal management because of using low thermal conductivity material. So we need to go one step further. What can we do on the cell level to better actively manage the temperature and prevent thermal runaway? So what available methods do we have today? Next slide, please. There were actually some traditional and innovative methods to manage temperatures of cells. The first one is mostly used in electric vehicles at the moment. It is an external cooling plate. So here the heat is transferred through the housing in a cooling plate, then to the outside of the battery. And there is no thermal management device between the cells. Here the heat conduction of the cell is relatively low. And therefore, there is a second approach applied to improve the heat transfer from cell to external cooler. And that is a passive cooling fin solution. So the heat transfer happens through cooling fin to external cooling plate and then to the outside of the battery. And there is also the method of active cooling plates. So here the cooling plate is in direct contact with cells at the site. So this is a quite effective solution, but the cost, the weight, and design space for the battery increase. It is applied, for example, in the Tesla at the moment, GM, Volvo, and other electric vehicles. Nowadays, some companies have introduced immersion cooling. So here, a special oil is used, and this oil here directly cools the cells. However, if you pump a liquid in the battery, the weight increases significantly. So you need an external equipment, and there is also the extra challenge with the pumping power needed. All these factors limit a widely application of this method. All these methods improve thermal management relatively, but none of these methods really solve the thermal runaway challenge. None of these methods is a complete solution for thermal runaway. You might think, yeah, but the second one, for instance, cooling fins between the cells, that should help. Yes, and it helps to vertically cool the cells, but it does not prevent the heat transfer, the thermal runaway in the horizontal direction. Next slide, please. So, what would be an excellent solution? A solution would do both. optimal performance in normal operations, and provide safety in thermal event. Now, this solution would set the ideal temperature for the maximum cell performance and would give more opportunity for fast charging. And at the same time, it would additionally prevent thermal propagation in case of thermal runaway. It would make safety from cell to cell, and it would isolate thermal runaway as well as keeping damage in a small area. And it is probably not a surprise for you that we are working at Stanley Black & Decker on such an innovation at the moment. Next slide, please. The innovation here is to solve the contradicting target between high battery performance on the one side and high safety requirements on the other side. And from an engineering point of view, this is getting even more interesting and exciting, because next to these conflicting targets, there's also tough boundary conditions. For example, the design space is very limited, and the cost, as you can imagine, must be low. With our research and development facilities in Asia, North America, and Europe, we are your development partner to work on such thermal management innovations and others. But there is more. Jane, over to you.
Thank you, Matthias, for this, and Brittany, for this great introduction. And hello again. Welcome to all of you from my side. Pressure and temperature are like a marriage, really, like husband and wife. You will often find them in the same spot. And over time, as they've been married long enough, they might even behave in a similar way. So I would like to use the coming minutes together with you to talk a little bit about pressure in the battery box and in the e-powertrain system, and how this can be managed effectively as well. So as Matthias explained very well, over time, processes like charging the battery, discharging it, or overcharging it and over-discharging it, as well as aging and corrosion, will lead to the creation of gases inside the battery system. Also, and this might in the worst case even lead to a thermal incident, or thermal propagation, where we need to rapidly evacuate a lot of gases. So these are the first type of pressures that we need to manage, namely those in case of a thermal runaway, in case of an emergency situation. Secondly, there are another kind of influences, namely those from the outside, the ambient pressure, which will also vary depending on where the vehicle is used. For example, at sea level, there is a different outside pressure than there will be on top of a mountain. So naturally, when using your vehicle and driving up and down the mountain, you will have to basically also balance out these pressures over time to keep the system happy and all functioning orderly. These is what basically is then called the normal operating functionality. As such then, in order to manage pressure, we need a system that can do both. One, as a breathing functionality, namely managing these smaller changes in ambient or outside pressure. And secondly, having the functionality of quickly degassing lots of liters of pressure within seconds in order to keep the situation safe for passengers in case of a thermal runaway or a thermal incident. Of course, when doing all of this, the system cannot let any dirt or any moisture get inside of the battery, because this would cause other malfunctions. So these are also very important requirements. I've brought along a short video of one of the systems that can show this as well. And the item displayed here, Brittany, if you could briefly start the video. The item displayed here, or some system that can do this, is a battery ventilation valve, which sits, in this case, as we will see here, on the outside of the battery box. It can also sit on the battery cell, depending on the cell design. In this case, it sits on the outside of the battery box. Such a ventilation plug, here abbreviated as vent plug, is especially there to have this connection to the outside world and to equalize the pressure, as we just described earlier, and in the emergency degassing, and of course also the breathing functionality. At Stanley Engineer Fastening, we have several POF designs for these functionalities, depending on what they need to be able to do, and of course, depending on the customer requirements. For example, the one you see here features the use of an internal membrane instead of a spring-loaded design, which reduces the assembly complexity, so makes it easier to handle, and also enables us to have a multiple-use functionality. What I mean with that is that in case of a thermal incident that is put under control very quickly, the membrane will just close again, have another gas-tight sealing, and will be ready to function again in the next situation whenever this one occurs. This is sometimes different with other designs, depending on how they are made. Also, we have a very easy, I always call this click-on system, single-sided access click-in installation that only requires a very low effort. So basically, in production, you can click the ventilation plug in place, and it sits there gas-tight. This means no gas can escape, only if it's wanted and if the plug will open. And of course, no dirt and moisture can get inside. So these are one of the products that we have at the moment in the e-powertrain and the battery box system that are quite interesting to look at. Especially, this product is a fine example of how they are created when we work together closely with the customer and when we are involved early in the development process. Especially, this is for us important to support early in the development process because it enables us to really analyze the problem together with our customers, and as such also realize cost and performance benefits early on in the design. Especially in and around e-mobility, we have noticed that because of these challenges that are still new, there are no fixed industry standards yet and no real best practice solutions fixed in the industry yet. As such, some problems are really still new and need to be analyzed very thoroughly in order to get with a comprehensive solution that solves all challenges. Here then, such a teamwork approach with a lot of transparency early on in the process and also a lot of involvement is very important and has created good results and resonance at our customers. It's also something we strive to continue as we are one of the key suppliers for EV and battery box companies as well in the industry.
Thank you, Jarno, and thank you, Matthias. That was a lot of great information. I know the crowd is eager to learn a bit more. We had some questions come in that we will get to. Before I do so, just a reminder, if anything kind of piqued your interest and you're interested in learning more and diving deeper, we're happy to kind of go through this co-development approach with you and your teams on your projects. Feel free to set up some time with our team. We'll be happy to do so. Also joining us for the Q&A session, we have Doctor of Engineering Alireza Akbarinia, our Manager of Electrification for Product Engineering and Development, and Guy Chun, our E-Mobility Business Development Manager for North America. Welcome to you both. So we will go ahead and get started with some questions. Jarno, I guess since you were the last one up, we'll start with one for you. So you mentioned that there are no real fixed industry standards yet, and many customers are still developing these new solutions for e-mobility challenges. What is your particular role in that?
Okay, so that's a very good question. It's also a correct statement, definitely. So as I mentioned on the last slide, we've noticed that especially in e-mobility, it's not as clear yet as maybe it used to be with a combustion engine on, let's say, which technical challenges there are and especially how they are to be solved. Yeah? We traditionally at Stanley Engineer Fastening, we have this history of co-engineering together with our customers, basically meaning that we are a partner for them already early in the development process onwards. This leads to a lot of level of transparency, which is also, of course, necessary in order to do this. So we need a level of trust, but it also enables us to optimize solutions very early in the process on, thus limiting the cost and, of course, also improving the performance. We have noticed, as I mentioned, that especially with e-mobility, this is very important because there are so many new things still to be discovered and solved. That's why this has gotten basically more importance again over time in the past years. That's our experience so far.
Great, thank you. Ali, let's have you speak to this one. Can your idea of thermal and safety be applied in energy storage systems too?
Definitely. We believe that the safety of the cell is exactly important in the same as in the EV and in industry. So in energy storage system, they use the same cell. So we believe that the safety and the thermal management in this area will be more important as the electromobility. So it would be a very considerable area.
Thank you. Guy, welcome in. Let's have you answer this one for us. How are you working together with your customers on these particular solutions?
Well, good morning, Brittany. Well, as Jarne, alluded to, through close collaboration. As you know, a lot of these solutions that we provide are not necessarily, off-the-shelf, items. So they do need a fairly significant level of customization. So once our customers identify their challenges, we try to bring our expertise in that segment in order to provide that solution. So because of that, we would like to get involved early in the process, as Jarne mentioned, so that we analyze the issue. We look for other areas that we might not have thought before, and then try to address those issues to customer satisfaction. So in short, close collaboration, and we would like to get involved very early in the process to make sure that all of the issues are definitely addressed and covered, and solutions are provided to customer satisfaction. Thank you.
Thank you. Great. All right, back to Ali and Matthias, one for you here. How important of a role is immersion cooling with oil going to play? Do you think all vehicles in the future will have it?
So we believe that the immersion cooling is a good solution, but as Matthias already explained, that there is a lot of limitation. It needs more equipment. It will be expensive. The weight of the battery pack will be increased, and the pumping power will be real challenging. Therefore, we believe that the technology is not enough to apply it for all area.
Perfect. Okay, so we'll stay with you for one more, Ali, if you don't mind. So do you see thermal runaway as a transitory issue until new cell technology is developed and scaled?
Yes, there is some differences. The goal of the cell is one of them is capacity of the cell, and another is safety. When we want to make more capacity and more driving distance, the safety will be more important. When we make the more safety with the cell technology, then the capacity will be lower. So this is the different material of the cell. So if we want the automobile industry want to have more capacity, more the driving distance. Therefore, we believe that the safety will still very important in this area. And this is always there is a high risk of the thermal runaway.
Jarne, going over to you. For the ventilation valve that you showed, do you offer products off the shelf? You mentioned that you have several designs ongoing.
Yeah, that is true. We indeed have several valve designs ongoing that are close to mass production or starting now. These designs are different depending on what the customer wants to have, depending on the ventilation behavior, the temperature requirements, the design space that we have, so smaller or bigger, wider. We are also experimenting with different materials than we used up to now in order to further improve designs and especially the requirements that we meet. So yes, in a certain way we have products available, but of course these are always specified according to what the customers want. So yeah, that's definitely something. But I have to mention again, maybe here, so the ventilation valve is a very fine example, but it's one of many hybrid parts, as we call them, that we have to assist customers in this field of production.
Yeah, good point. All right. So Matthias, over for you here. Do you have the necessary certificates for supplying automotive industries?
Yeah, thanks, Brittany. Since we supply the automotive industry since many years already, yes, we have all the necessary certificates available, like 16949 and others.
Perfect. Okay, one more for Ali here. Which solutions for battery cooling among the 4 solutions that were presented do you see as gaining more importance in the future? The cooling plate, active cooling plate, etc.
So this is very, very good question. The automobile industry are always searching for this cheaper ones and most effective ones. So we believe this is some combination of the solution will be the final solution. The passive cooling fins is one of the good ones in between the cells, but we need some transfer method approach to remove the heat from the battery pack. That means there's some combination of the cooling plate and the passive cooling fin will be most important and will be the cheapest ones finally.
Right. Okay. One that I can actually speak to, I guess. Will this presentation be provided after the event? Yes, following this event, you'll get an email from us with a link back to watch this webinar recording as many times as you like. As I mentioned, we're happy to provide any additional documentation, anything else that we can provide you with a little bit more information, or meeting with us as well. But yes, there will be a link provided to you. Okay, great. Well, I think that wraps up all of our questions for today. Thank you all so much, presenters, speakers, Q&A joiners, attendees. Thank you to everybody for joining us today and participating. As mentioned, we'll include those links as a follow-up for you following this event. There will also be a survey form that will pop up on your screen here. We would greatly appreciate any feedback that you have on today's event. Any suggestions you have for additional topics coming up. We have some more great EV events and content coming in the coming weeks and months. So we hope to see you there. And from all of us here at SEF, take care, and we hope to see you again soon. Bye-bye.
Thank you. Bye-bye.
Bye-bye. Thank you.
Thank you.